The broadcast is now starting. All attendees are in listen-only mode.
Okay, good afternoon, everybody, and this is the seismic review. I hope that all of you are healthy and are in good condition and ready for the exam. I don't know if the exams are still scheduled as before after this increase in the cases. I heard, for example, the FE. I have a friend, he's supposed to take the exam on Monday, tomorrow, the 29th, and they pushed it to January 21. I have no idea. But this is another site or another testing site. Is not Prometric. It is the other one for Pearson's. Yes, Pearson's testing site. So for some reason, this what I got a text from him that they moved his date all the way to January instead of June 29, which is supposed to be tomorrow. So anyhow, I hope that the situation for seismic is different, and they are still having the exams at the normal schedule as they promise you guys to. One thing that I want to discuss, maybe maybe they will ask you, and I do have a problem. For some reason, I print it and I left it after I finished this morning class at about 11:30. I went home very quick to take care of something urgent, and I had very quick lunch, and I came running. And I printed and I left it somewhere. So probably during the break, I will try to locate it and discuss it with you. If not, I am working on the schedule right now for the third quarter. For the seismic and for surveying, seismic, and the third quarter for surveying. So it will be these two subjects, since already I taught them, and you have access to the on-demand as I announced before. So in this case, I will have workshops for both of them, workshops, and I will try to do my best to have as many workshops as I can, similar to what we have right now for the current one. So I believe and let me know if you feel that this is not very effective. I feel that, for example, the seismic, we have 7 workshops, each workshop 3-4 hours, 2.5 hours, and so on. So if I maintain the hours to be 28 hours, I believe is more than enough. This is exactly like a course. Some other vendors, they teach the entire course in 28 hours from A to Z. I need to devote these hours. I will try to make them as close as I can to this, and I will spread them over July, August, and September, and you will get so starting July, August, and September. This is the third quarter, and the fourth quarter, obviously, it was going to be October, November, and December. This is the fourth quarter. So fourth quarter, maybe I can develop. I'm almost done with the third quarter for seismic and surveying the schedule, and you will have an ID, and you will be able to join me. Those who are already took the class with me before, either the first quarter or the second quarter, they will be entitled to take the class again in the third quarter. Even I allow also the fourth quarter because of this. Normally, I'm very flexible as far as the time. So you will get the ID, okay, for the third quarter at least now, where you enroll once and that's it. And I didn't decide yet to make it free or not. I know this quarter was for free, but I will decide to see if it's going to be free or not. So this is all these were free during the summer. So I said, let keep everybody busy, staying home and doing something useful to you and something that it will help you for the exam and for your registration is very so very soon you are going to get an email from us or from me. I'm doing most of the work myself nowadays, as I told you before, and I hope that I am doing a good job. But I will do all my best. There was a chapter about geotechnical, chapter 11, chapter 6, 7, 8, 9, 10, I believe 11, yes. Chapter 11, it was talking about the geotech. Chapter 10, let us see if, yeah, it is chapter 11. It is retaining walls, foundations, and some geotechnical topics. Sometimes, I don't know how often they ask this question, but sometimes they ask about the in the chapter 11, which is the geotech and soils, or soils and geotech. They ask about the stability of retaining walls. I know this is a purely geotechnical stuff and is not really but just in case, so I prepared, this is about 10 years ago, I do have this problem, a geotechnical problem, taken into consideration the seismic. So if you do have a cantilever retaining wall like this, it is having a backfill. Let's take this watermark here. There's no water table here. Let's make it easy. So the backfill is here. And we might have backfill here, by the way, on the other side. Maybe some soil here. Let's consider both. As you know, this we'll call it the stem. And this is the toe. And this is the heel. And this is the chapter 11. It does have the parameters that are affecting the stability for the retaining wall already. Here it is. This is the one I was talking about. This is the heel, and this is the toe. And this is the active side, and this is the passive side. So the two equations, already I list them here, equation 11.1 and 11.2, which is a factor of safety against overturning and factor of safety against sliding. And there was a statement, I told you, please pay attention to it, because the minimum factor of safety for retaining walls against sliding and against overturning is 1.5. Based on IBC, it is minimum of 1.5. So this is using the allowable stress design, because, okay, we're talking the factor of safety is used only for allowable stress design, as you know, not for the LRFD or the stress design. So if you do have a retaining wall, so the per code, per IBC code, International Building Code, factor of safety greater than or equal 1.5 is required. And this is for the sliding, or against sliding and against overturning. Overturning. And I discussed all the parameters and I wrote the equations for the factor of safety, which I can remind you with these two equations. Factor of safety against sliding is basically the ratio between two things. The factor of safety, by definition, is a factor that having the ratio of resisting over disturbing. So sliding, we have resisting forces over disturbing forces. And this must be greater than 1, because a factor of safety, as I told you, minimum 1.5. If you can make it bigger factor of safety or better factor of safety, that's good, but it costs you money. The larger the factor of safety, as all of you know, the costlier the structure will be. This is why codes like IBC code, they try to make a balance between safety and cost. Safety and cost. Okay. And I don't know if you got or you felt the earthquake a few days ago, Lone Pine. In fact, I was where I was. Yeah, no, I was in the office. I can't believe, or at home, I can't remember. Anyhow, and we felt it in Fresno, California. Lone Pine is northeast of us. And I said, okay, I told my wife, I think we're doing something here in the office, bringing something or passing by, I can't remember. And told my wife, this is a magnitude of 5.8 or 5.9. I told either 5.8 or 5.9. And it came exactly 5.8. She told me, how do you know? I told, just, I guessed, and I guessed it right. So based on my experience, based on even knowing, without knowing where the epicenter is, but I guessed it right. So there is a disturbing force due to this magnitude 5.8 or 5.9. Okay, so it could cause damage to some retaining structures or retaining walls at this one here. So the factor of safety against overturning, it is also resisting over disturbing. And since here we are talking about overturning, so we're talking about resisting moments divided by disturbing moments. And again, this must be greater than 1.0. So the safety and the cost is a balance that has been made by the code or by codes in general. When they develop codes, they tell us, okay, we are going to make your structure safe, Mr. Mansour, but also we are going to make it economical also at the same time, because we cannot really design our buildings for a magnitude of 10, M10. If we design every structure for a magnitude of 10, it will be extremely expensive, and nobody can afford a house, or very, very few, let me put it that way. Because a magnitude of 10, the cost of the structure will be huge. But what is the probability that a magnitude of 10 will happen during my lifetime or your lifetime? So we're saying that's very, very low. So this is why we said that even if the magnitude of 10 is theoretically speaking never happened, it could be 9 or 9.6, like 1906 earthquake, San Francisco earthquake, 9.6. So we make always, or the codes make a balance between this and this. So when I say that I try to make the factor of safety as a minimum 1.5, you could make a factor of safety of 2 or 3, whatever you want. As long as you exceed the minimum required by the code, you are okay. But a factor of safety of 4 or 5 or 3 or whatever is going to be costly. And this is why for high-rise buildings, and probably I mentioned that before, for high-rise building like the multi-story building in San Francisco, the condominium building, 110 stories, I believe. Uh, uh, um, the one start to they drive the piles, but the piles, unfortunately, it didn't go through enough, or didn't go to a very good soil, hard rock. So the hard rock, which is the best soil area, do you remember hard rock? This is the soil type A in the table in chapter 6, table 20.2-1. Okay, I'll show you the hard rock. So normally we try to locate from the boring log where is a hard rock layer, and we try to drive the piles such that the piles will be resting, so the piles will take the load from the structure to the hard rock, and this is the best. It seems to me that they don't have a very good geotechnical report, and the building start to lean, and there was a 60-minute segment, the building start to do this. I'm serious. It just, they put a steel ball on one side of the room, and the ball was running the building like this. So the steel ball like the here, obvious, I'm exaggerating, and the ball is running. So they start to drive piles, and anyhow. So a factor of safety for piles, we use factor of safety of 6 or 7. Factor of safety, just in relation to the retaining wall, which is 1.5. Factor of safety for piles 6 or 7. Okay. Why? Because when you drive them, you will not see them again, my friend. That's it. You drive the piles, and you will never see them again. Okay? A retaining wall, we are going to see it, and we are going to repair it if there is something went wrong. But here, no room for mistakes. And that's why, in order to do this to the best of my knowledge, based on the report I saw in 60 Minutes, as you know, there is NBC News, NBC, they have 60-minute segment, which will be tonight on Sunday between 6 and 7. No, 7 and 8, sorry. 7 and 8 California time, 7 and 8. I'm watching this 60-minute NBC, yeah, NBC. Or CBS, I can't remember. NBC or CBS, whatever it is. One of these channels. I remember channel 47. This is what. So they went to the building, and in order to fix this is $100 million. And they are still working on it. $100 million to fix this. Driving additional piles, and hopefully they can stop the building leaning, like the leaning tower in Italy. If you remember, there is a tower in Italy, okay, start to lean, okay, and it is a tourist attraction right now. So anyhow, so the factor of safety when we're talking about is very, very important. So the factor of safety by per IBC is 1.5 for overturning and sliding, but this is under static loads only. And this is mentioned in my book, by the way, on page 415. 415, page 415, you will find that the definition and the statement I'm referring to, that when a subject to static earth pressure, here it is static, IBC, the factor of safety, 1.5. The factor of safety under static pressure may be reduced by 1/3 when considering the combined effect of the static and a plus, and you see the plus I put here, and the seismic earth pressure. So they said that we can reduce this factor of safety from 1.5 to 1.1. This, by the way, as I mentioned in the class, it used to be in the previous code. They are no longer adopting this policy, which is stress increase. We do it only for wood, 60%, but the 33% was a philosophy at one point of time codes were adopting the increase of the stress by 33% if we combine the earthquake force. So if we take the 1.5 and we adopt this, so it is 1.1, the factor of safety, um, uh, combine the static and the earthquake. I believe it is mentioned also, it is mentioned somewhere, let me see. No, it's not here. No, okay. So I needed to remember that. I needed to remember that the factor of safety 1.5, it is for static. So it is 1.5 for static only, and 1.1 as a minimum for static plus dynamic, or the earthquake, which is the dynamic. Okay, and so I needed to remember that. It's still safe, by the way, still safe. And the justification that they are using lower factor of safety, 1.5, because the dynamic is a not permanent load, okay? And it is happening, okay, at very short duration. And in order to consider the dynamic, Dr. What's his name? Dr. Oh, I showed you the book. Where is his book? I have it here somewhere. Yeah, here it is. Here it is. Dr. Kramer. I should not forget this. Stephen Kramer, Geotechnical Earthquake Engineering, as I told you, one of the best books available in the market, or the one I am aware of. Okay, maybe there are some other books I'm not aware of and maybe better, because I used this book twice when I was teaching a class, and I used also when I took a class back in Las Cruces, New Mexico. That's why I am so influenced by Dr. Kramer's book. So he has some good problems about the geotechnical and the entire book. It's a very thick book, by the way. It's a very thick book. Okay, you see, it is how many pages? About 652 pages. So it's not a little tiny book. So it's talking about the. He discussed it very, very well. Okay, so this is what I need you to know. I need you to know this and this. Okay, this is very easy. I draw just a retaining wall, cantilever retaining wall, under static only. So I have two forces. If we have an earth on the other side, so I have what I have, let me select a color, different color. So this side here, which is active, so this is the active side. And the opposite side, if the earth exists on the other side, is called passive. So this is the passive, and this is the active. And there is a reason why we call this active and this is passive. Or this is why the scientist, okay, because of the backfill, because of the soil is trying to push the wall this way. So the wall, if the wall is moving away from the backfill, we call it active. If the wall going into the backfill, like this soil here, we call it passive. And we have two forces. We have active force, which is B sub A, and we have a passive force, B sub B. These two forces, basically the area of the triangular distribution. And let me move to the second page, at least I can write it clearly for you. So if we do have, this is the active pressure, which is a triangular distribution. So this here is the maximum, which is gamma H. So if the height is h of the retaining wall all the way to the base, this is gamma h. And we multiply, gamma is a unit weight, by the way. Gamma is a unit weight. How many pound per cubic foot? And the h is height. And this distribution is linear, assuming that the pore water pressure is zero. We don't have any pore water pressure. So we do have a force here. Okay. And this force is acting at the centroid, which is at h/3. And this is the P sub A. And from here to here is h/3. And this is the centroid. Since we are dealing with soil, and I needed to remember this, when you have a water tank, and we remember this from the national exam, you have a water tank, or a tank has water. The water has also, if this is H, if this is the depth of the water, H, so the maximum pressure here is gamma H. And the pressure also is linear, increasing from zero at atmospheric pressure all the way down to the maximum pressure. But this is water. This is soil. Soil has gamma. It does have phi, whatever the angle is, 32 degrees or 30 degrees, which is a backfill. Here is a backfill, the soil. So the soil has shear strength. Water does not have a shear strength. This is why we multiply this times K sub A. K sub A is called active earth pressure. Active earth pressure. And this is K sub A is less than 1. It's about 1/3. And is given by this equation. K sub A is equal 10 square 45 minus phi over 2. So if the phi, the angle of the internal friction is 32, so K sub A is equal 10 square 45 minus 32 divided by 2. So in this case, if you allow me to calculate this very quick, you will find about 0.3. So it is 45, 16 minus, and you can take 10 and square it, is about 0.31 or 3073 if you like to get it. So the total force P is equal what? Is equal the area of a triangle. Is 1/2 base times height. So it is 1/2. The base is Ka, what's K sub A, gamma H, and you multiply by the H. And this is why we remember this is 1/2 K sub A gamma H squared. Do you remember this equation? I'm sure that you remember it. This is the active side, which is this one here, which is next to the heel. This is the toe. The other one, if we do have soil on the other side, if we have soil, if we don't have soil here, that means there is no passive. So if we have soil on the other side, so the distribution will be like this. Also linear. Okay. And assuming that the soil on the other side is up to this height, I will call it H2. Let me call this is H1. I believe I was planning to use H1, but I forgot. So H1, 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 and H1. Not H1N1 virus. Do you remember H1N1? They were talking about this morning. So right now, I do have also a force here. And this force, we'll call it P sub P. And this is H2 over 3. And this is H1 over 3. And the P sub B, this is called the passive force. Passive force. I know you remember all these things, but And the P sub B in this case, P sub B is equal what? First of all, the pressure here, by the way, this is gamma H2, and we multiply it by something is called K sub P, which is a passive. And the P sub B in this case, B sub B is equal to the area. It is 1/2 K sub B gamma H2 times H2. So this will give you 1/2 K sub B gamma H2 square. And K sub B is called the passive earth pressure. And this is greater than 1, by the way, is not like the K sub A, because the equation K sub B is equal 10 square 45 plus phi divided by 2. This is minus. Remember the difference between this and this. So if we use 32 degrees, the one I use it here, so it is 10 square 45 plus 32 degrees divided by 2. You will find this number is larger than 1, in fact around 3, by the way. So 16 45 plus 10 second square, bingo, 3.25. Because in fact the K sub B is equal 1 over K sub A. Always, I need you to remember that. If you take the inverse of this, if 0.3070 and take the inverse, it will give you this number directly without calculating. So I need you to remember that. So far, no change, and this is what I included in chapter 11 of my seismic book. I hope that you like the book. I got a very, very good feedback from the people who were using the second edition as, the fifth edition as the first and the second and third. I did all my best. In fact, it is self-contained book. I cannot assume that's immune from typos or mistakes. There is nobody can claim that. Nobody can author a book and say, I am 100% cured or immune immune from any typos or mistake, but I did all my best over 30 years, and I get a very, very good positive feedback from the engineers who use it. They consider it a very good book for preparation for this exam, and they use it after even the exam. So try to get the maximum benefit, and if you find a typo or a mistake or an error, let me know. Nobody above mistakes or typos or errors, as I always say. So all this is nice and straightforward. But now we know where is this H1 over 3 and H2 over 3. So we know the location because we know the centroid. What is really was a mystery to the professors and to the scientists, where is the seismic force will be acting? The seismic force will be acting. So I am taking you back to the same figure, and they agreed on H over 2. The horizontal acceleration, which is M times AH. So in addition to the active and the passive forces, we are adding another force here. The acceleration must be given to you, the horizontal acceleration, and the mass is given, multiplied, and the moment arm or the arm is going to be H over 2. This is the whole story. So when I locate the problem, if I'm able to locate it today, if not, this will be the first thing that I will discuss it during the first meeting in July. Okay, this retaining wall problem, because just in case if they ask you how to calculate the factor of safety, I have a very long problem, if I remember correctly. As I told you, I print it, and I will locate it here to see if I can print it from the USB I am carrying. Will be a good idea. So I need you to be aware of that, just in case if they ask you this question, and you might say, wait a second, why they are asking some geotechnical questions uh, uh, in seismic. I don't know. I really don't know. The only thing I know that I will do my best anything I feel or I believe that it might be a target for a question on the exam, I discuss it here, and I would be glad to discuss any issue that you are concerned about as far as the exam. Let us take a few minutes break, and let me. I know I was just only 45 minutes. Let me, if I can locate this problem very quick, I will print it and come back so we can. Um, um, and also, I need to prepare a cup of coffee. I prepared it, but I didn't drink it, or I said I didn't finish it. So let me go and prepare a cup of coffee and grab a cup of coffee, so at least we can, okay, uh, survive together. Okay, let's meet after 10 minutes from now. Thank you very much. Okay, welcome back, everybody. So the retaining wall, I was not able to find the problem here. I am not able to get access to it, so I apologize for that. But it will be the first lecture. I will meet with you guys. I will be glad to I will send it to you. And the first lecture we meet in July. Unless somebody is taking the exam before that and you would like to have a special session. Anybody is taking the exam very soon, by the way, the first week of July, or anybody, you don't have to tell me your name, but if you raise your hand, I will know it from here. Anybody is taking the exam? I wonder, is Prometric still sticking with their original schedule with you guys, or they already start to pushing, as I heard from another friend about the FE. They moved it far away from June 29th till January 2021. So it was a huge move, a huge jump. So I don't know what is the policy for Prometric after the cases of corona start to increase again. Are they going to shut down again? Are they going to anybody is taking the exam very soon? Let me put that way, July. Anybody? I remember there was one of you told me that in June he's going to take the exam this month. I don't know if still scheduled for June or they moved it. Anybody is taking the exam in June? July? What about July? What about August? Anybody is taking the exam in August? August. Okay. Nobody is raising the hand. It seems to me that. Or you can write it in the question area if you don't have the control panel in front of you. And now, please let me know. Please let me know. Let me put it that way. If nobody is taking the exam very soon, please do your best. Keep active, and I will keep you active. I will come up with a very nice schedule for the next quarter, and I will do all my best to have it around this figure here. I need to see the other classes, which will start in July, the transportation and civil Brit EM and uh, and the construction. So probably I will do my best to get to come up with the schedule that very reasonable. And probably I will email you first, because I wonder, do you prefer the weekdays or the weekends? I really don't know. I got a response from one of you here. I reschedule for November. Okay. I got an email from. Okay, so it seems to me yeah, that's fine. That's fine, Sam. Okay, do your best. Okay, and Haas also do your best. Um, 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 but don't slow down. I don't like to say, oh, my exam is in August, so I am far away. And slow down. Don't slow down. Just keep the 626 is a wonderful book, and the software is working fine. And if you have any problem with the software, please let me know. Don't wait until the last minute and after that tell me the software is not working. No, it's working, and if you have technical issue, please let me know. If there is a typo or mistake or an error, please let me know. Yeah, you have the largest number of problems available in the market. There is no any. I am way before all these people available in the market right now. Or most of the vendors, if not all, I can say all right now, because two of them they are no longer Dr. Chalabati and PPI. So we started together way back, PPI and Irvine Institute of Technology, Dr. Chalabati. Both of them are no longer offering classes. So I started with them way back. So I'm doing my best. Let me put it that way. I'm not claiming anything other than just I'm doing. So I have a very large collection of problems that developed over 30 years, and I'm doing all my best. So try to solve all these problems, not once, not twice, but I would say that I don't know more than that. You have the computer program. The computer program will generate CBT, and we'll do it. We'll do it. Okay. So so it is. Do your best And for example, let us look to this problem here, 579. Can you go to 579 of the 6 to 6, 579 on page 217, please? Page 217. So if you read the problem, a building used as a storage facility is shown, and it is assigned seismic design category SDC, seismic design category C, as in Charlie. And the dead load for the roof and walls are given. Dead load for the roof is 18 pounds per square foot. And it is half an inch structure one plywood with 10D nails. And the walls are the dead load 16 pounds per square foot. It is half an inch also structure one plywood with 10D nails also. And he said that the diaphragm is a blocked diaphragm. And this is a plan view, and this is a cross section. This is a parapet, as you know. This is a parapet, which is extension parapet, the extension beyond the roof. And this is a plan view. And he gave us loads. And here is the north arrow. Very important to know the direction. Pay attention to the direction, please, because we need to make sure that you are solving the problem in the proper direction. So direction of analysis is very, very important. And as you can see here, we have the following. What is this? When they have something like this, and they cross it like this is a plywood sheathing. And this is 8 feet, and this is 4 feet. We know is 8 by 4, or 4 by 8, as we call it, 4 by 8, 32 square foot. This is a plywood or OSB, oriented strand board, OSB. So the plywood sheets are arranged this way. And there are some members, these members here, these are the joists. So there are members running this way. These are the joists. If you let's call it rafter, I have no problem. A beam. A joist is a beam supported by the outside parameter of the building. And we put the plywood and we nail the plywood to the joist. But he said that it's blocked. So we are putting a piece of plywood like this way, perpendicular to the joists. A blocking. Do you remember blocking? Which is shown in chapter 10, at the beginning of chapter 10. This famous picture, which here it is. These are the joists, the plywood, and the perpendicular pieces of wood that they are perpendicular to the joists. We call them blocking. So we can drive nails here. This is why we call it a blocked diaphragm. And this is one sheet. This is 8 feet, and this is by 4 feet. And the joist, by the way, if you look to this drawing here, which is figure 10.4, this is one plywood sheathing, which is, here it is, 4 by 8. This is the narrow dimension. This is a 4 feet. And here are the joists. You will find that the joists are parallel to the narrow dimension of the plywood. Here are the joists. I use different color here too. And this is the strong dimension, by the way, or strong direction. So when we put the plywood, we put it along the strong direction. I believe there is a picture. Let me see if I can find it in one of my other books. Maybe in construction book in chapter 7 or chapter 8, materials, when I discuss wood design or wood construction material. Yeah. And this is available also. I didn't invent the knowledge. It's just a strong direction of plywood. Okay. So if you look to this, this is a 4 by 8, 4 by 8. So this is one plywood sheet. Here it is. Probably in the future I can include this drawing. And these are the joists. So this is for, you'll find the joists are running parallel to the short dimension, which is a 4 feet. Okay, so the joists are running this way. Here I didn't show any blocking, by the way. These are the joists. You see that? This, because the orientation of the, if you look to the cross section AA, how they form the plywood. The plywood made of layers, as you know. So based on the manufacturing, there is a strong direction. So this is the strong direction of the plywood, that we place the plywood such that the narrow dimension is parallel to the joists, parallel to these beams. You see that? Okay. So this is called the strong direction. Okay. I'm glad that I remember the page at this. So we do have the problem. Let's go back again to the problem. So the joists are running this way. And the plywood are placed. So the joists are parallel to the 4 feet dimension, as you can see. And the first question related to this, you remember that we have 6 cases. Case 5 and case 6, the continuous parallel joints in both directions. But here he did not include case 5 or 6 among the answers. And I needed to know that case 1 and 3, they go together. And case 2 and 4, they go together. So if one direction is case number 1, the perpendicular direction must be case number 3. Must be, because they go together, as you remember. And case number 2 and 4, they go together. So this is an easy one. Is asking the load case for the given in the east-west direction. and in the north-south direction. I look to the load. If you remember the discussion we had, the load case, there are two criteria in chapter 10, we cover that. The load case is determined by looking to two criteria: the load direction with respect to the continuous panel joint. So again, you should know exactly where you can find the information. The load case depends on two factors. Here I am on page 364. Nobody will ask you to memorize tables and the charts and equations, but you should know where things are located in the book. Either my book or in another book. It does not make any difference for me. Or if you're carrying the code with you, I have no problem with that. So the direction of the lateral force, and if the diaphragm is blocked or unblocked. Unblocked edges if the diaphragm is not, or blocking is not provided. And here, for example, we look to this. Based on this, these are the 6 cases provided by the code, the special design provisions for wind and seismic, which is little tiny book. I showed you about 10 times, and this is number 11. If I'm counting, just kidding with you. Special design provisions for wind and seismic. These are the cases listed in these tables. Here are the 6 cases. This is what I did. The 6 cases. So we need to make sure that we understand that. So case 1 and 3, they go together. And case 2 and 4, they go together. Case 5 and 6, they go together because the continuous panel joint perpendicular and parallel to the framing. So we have a continuous panel joint in both directions. So case 5 here. So this is case 6, go together. Case 5 here, case 6 here, they go together. One direction, 5, one direction. Here, case 2 and case 4. And case 1 and case 3. And I believe I explained this very well, and I hope that all of you are familiar with this very well. And they might ask you, I don't know if they can ask you these easy questions or not. I wish to determine the case. This is piece of cake. And as you can see here, also they mention the 2 scenarios, that the long direction perpendicular to support, which is always the preferred one, because this is the plywood and the framing are running this way. So the short side is parallel to so the long side is perpendicular to the support, which is the joists. The other case is here, is the long panel direction parallel to this, perpendicular to this is parallel to. You have to be careful about that. You see, these are the joists are running this way, and this is the long side. Okay. And he said that there is a footnote here, A. I doubt that he will ask you about that, but normally we go with that's which is a strong direction, but just in case. But this is for the design. No, I doubt that he will ask you. to go over the design issues. Okay, and I mentioned in the class that load cases 5 and 6 have continuous panel joints running in both directions. And also I mentioned that load cases 1 through 4 are the most common one compared to 5 and 6. So these are most common ones. But the continuous panel joints in both directions, like case 5 and case 6, are the least common ones. Make sense? Okay. So this is an easy one. And as I told you, that look to the load, the applied load. Here, the load, the continuous panel joint is here. So the load is perpendicular to the continuous panel joint. And is perpendicular to also the blocking. So in the east-west direction, the load is coming this way. The load is east-west. So the continuous panel joint this way, this is it's called continuous panel joint. Here it is. Continuous panel joint. Continuous. But here, no, we have a joint here and a joint here. So the load is parallel to. Here, in this direction, the load is perpendicular to. So I look to the cases and determine, and this is very easy. Make sense? Any question about that? So what's the answer for number 579? Answer A or B or C or D? East-west, the load is parallel to. So case number, answer A or C. If we are looking to the east-west direction, where the load is parallel to the continuous panel joint. I'm waiting for an answer. Either answer A or C, because these are out. Okay? I got an answer from one of you. Okay. Case 3. Good. Okay. So if you go to the answer, I did all my best. 579, that is 579. There it is, 579. The case is, or the answer is C, as our friend is case number 3. Okay, the load case essentially depends on 2 factors. And I look to that, the applied load force in the east-west direction is parallel to the continuous panel joint. Therefore, it is a case number 3. This is my answers. And again, if you look to my answers, I did all my best to provide you with as detailed as I can. You cannot believe it. How much time does it take from me to develop these books? Just years after years after years after years. And the thing that really helped me too much is teaching. When I'm teaching, either at New Mexico State or Fresno State or CSU Fresno, 30 years teaching, they helped me a lot. Over all these years, I collect all this knowledge and all this information and all this, because every time I teach a class, I learn something new. Every time I teach a class, teaching is a very, very useful tool as far as learning. I always learn something from each course I taught, even if I know I know the material very well, but it's still learning something. Okay, good. Okay, so everybody is awake. Number 580 is asking about the north-south. So if this is case number, so this must be case number 1. because case number 1. So this is why equation 580, it's supposed to be the answer is A. This 4 is a case number 1. And case number 1 and case number 3, they go together. Okay? So these are easy stuff. Nobody will, I don't know if they are going to ask you or this or not, but the aspect ratio is very important. If you flip the page, problem 581, the diaphragm length width ratio, which we call it aspect ratio. Aspect ratio, we have 2 aspect ratios, one for shear walls and one for diaphragms. And there are 2 tables, one for diaphragms and one for shear walls. Okay, and I showed you this 2 tables, and here is one of them. The first one, this is aspect ratio for diaphragms. Here it is, L and W. Do you remember this drawing? This is a table 10.1, which is taken from the special design provision for wind and seismic. Okay, so we'll come to this table, and unblocked and blocked, those are the 2 most common ones. And this is on page 366 of my textbook. Make sure that you have my books, and if you did not receive the 5th edition, let me know. If you did not receive the other 2 books I sent, which is called the white books, the white cover, the one that does have the ATC 20, I believe I sent it to all of you. Unless if I forgot anybody, please let me know. ATC 20 and the code stuff, the code chapters. Also, it was a white page. It was okay. The code starting with the IBC 2018 CBC. So if I remember correctly, I sent it to all of you. But if simple email, I will do my best. I am working by myself in the office, but I will keep working with you guys until the exam day to help you to prepare for the exam. And so the aspect ratio, either 3:1 or 4:1. Length width ratio. And we know what's the definition of length, and we know the definition of width. Length is always perpendicular to the load. Always. Here it is. So when he's asking, because they are interchangeable, length and width are interchangeable. So when they are saying that the length width ratio in the north-south lateral load, so we're talking about this load here. So this is the length, and this is the width. So this is 55, 25. So this is 80, and this is 40. So L is equal 80, and W is equal 40. So L over W is equal to 1. And the answer is B. And the table I was talking about, by the way, in chapter 10, this table here, the word maximum is very important. This is a maximum. You can go below the maximum, but this is the maximum aspect ratios for diaphragms. Makes sense. Okay, so it is 2:1, and this is a blocked. A blocked is up to 4:1. Are we okay? Yes, we are okay. We are below the maximum. So far, so good. 582. Assuming the north-south uniform seismic load, W sub S is 210 PLF. It is again north-south. Here is a north arrow. So this W here, WS here is given to be 210 PLF. The diaphragm chord force at point E, there is an opening, is most nearly. I solved this problem before. I told you this. We know the chord force is equal to M divided by the width. Chord force. Or, no, this per unit length, no. The chord force is the moment, here it is, there are two equations, the chord force and the, in chapter 9, sorry, let's go to chapter 9 to give you the equation 9.1 and 9.2. I try to use the same, yeah, chord force is M over D, I use D, okay, that's fine. I put W automatically. So the chord force is equal the moment over, not W over D. This is why I said let me correct myself very quick to make sure that we are using the same notations. So they are using D for the depth, which is W, by the way. It is M over D. If you write it as M or W, I have no problem with that. This is equation 9 what? 9.1. But the moment, I need the moment here. And I told you this is a structure analysis problem. So I have the diaphragm like this. This distance is 80 feet. And I have the load. The load exists, or even over the opening. But the point E is here, which is 55 feet from this end or 25 feet from this end. And this is 210 PLF. I know the maximum bending moment is a parabolic and is WL squared divided by 8. Do you remember this equation, WL squared divided by 8? But I need the moment here at 25 feet. So in this case, we have to be ready for that. So if I do have a beam that is 80 feet span length, and it carries this load here, and this is 210 PLF, and we have a point, he called it E, and this is 25 feet here, and this is 55 feet here. I need to get the moment at E. Oh, this is piece of cake. I can take a free body diagram. I can come and cut here, and this free body diagram is like this at E. And this is 25 feet. And let me call this is A and this is B. So this reaction here at A, it is A sub Y, which is equal to 210 times 80 divided by 2. And there's a shear here and a moment here. This is the moment at E I am looking for. So if I sum moment here, so the moment at E is equal to this reaction here, which is 210 times 80 divided by 2 times the arm is 25, minus, because the load is coming this way, I still have 210 here over 225, so minus 210 feet times 25 times 25 divided by 2. This will give me the moment at this point here. So the reaction times the moment R minus this load. So in this case, I will say 210 enter 80 times 0.5 times. So 210 enter 80 times 0.5 times 25 times. I will store this, and 210 enter 25 times 0.5 times minus. So I found the moment here. One more time, let me do my calculation one more time. I got 144,375 pound foot. I don't know if you got the same number or not. Since I know the moment right now, I can get the chord force at here, at point chord force is equal to the 144,375 divided by the depth, which is 40 feet. So if you divide this by 40 feet, 40 divided, I get a 3609 point something. And this is in pound, by the way, because this is pound foot and this is 40 feet. So 3609. So if you look to the four possible answers, 30, 26, 30, 36, probably the answer is C. Can you do this in 2.67 minutes? Yes, yes, you can. 2.7 minutes. Yes, you can. For the same problem, by the way, if he is asking you what is the maximum, I don't know if I ask this question or not. No. If I ask, okay, what will be the maximum chord force will be? Maximum chord force. Maximum chord force. This is a problem number 582. It will be way more than 3610. It's equal to the M max divided by D, or the M max divided by W. M max is W WS L squared divided by 8 divided by D, or W. So in this case, it's 210 times 80 square, WL squared divided by 8 divided by 40. Let's do this and see what will be the number for the maximum chord force, which is at the center, by the way. It is 210 enter and 80 seconds square times divided by 8 and 40 divided. So this would give you 4,200 pounds. Obviously, it is more than 3610, the one we found before. Probably next time, probably, but you promised me that you are going to, probably I will put 4,200 here. Let us, okay. So this is a maximum. This is a maximum chord force because, as we know, the distribution of the chord force is not linear, it's parabolic. So this is the beginning of the diaphragm, and here it is. So it is like this. And this is the maximum at L over 2, by the way, L over 2, and this is L over 2. Or this is 40 feet, and this is 40 feet. And this is the WL squared divided by 8, as all of you know. This is M max. Don't forget that. Any civil engineer should remember that. I was joking one time, you probably heard the joke that even while he is dying, if a civil engineer we ask him about what is the maximum bending moment for a uniformly distributed load supported by a simple beam is WL squared divided by 8. If he didn't give you the right answer, don't put him in the grave. No, just kidding. Okay. So the point E, as you remember, it was here. So the point E, it was only 25 feet away from the end, is not 40 feet as here. So I'm expecting the bending moment here is less. The reason I'm calculating this, because somebody may say, I don't have time to calculate the bending moment here. Can I proportion as 25 feet over 40 as the M max, which is 210 8 square divided by 8 divided by the unknown value here? Can I proportion like similar triangles? So it is 210 80 second square times 8 divided. And I will tell you why I'm doing this, because somebody asked me this question. I told him, I will not do it. I will not do it. Try to do your best. So, okay. So this here is a ratio. I said 25 over 40 as this dimension over this dimension. Or let us do it right. Since I put this in numerator, so it is x divided by the 210 80 squared divided by 8. So in this case, I will say that 80 second square 210 times 8 divided 25 times 40 divided, I get 105,000. This number here, by the way, the maximum bending moment, the one we got before, was 144. You see, we got 144, 375. 144. Here it is, 144, 375. Using the structure analysis equation versus 105, which is a proportion this over this as this distance over this distance. In this case, you are assuming like this. If you did that, you are assuming like this, linear. That means that this value here is a 105, yes. But I'm looking for this value here. Do you see the difference? Because it's parabolic, it's not linear. So you are really ignoring. So 105 versus the 144, 375. So I need you to be aware of these things. Okay, as far as any topic you want me to go over it, or first of all, let me ask you during the second quarter, the third quarter, because the third quarter I will start to teach the national exam, as you know, transportation and construction, and the national exam and the civil AM, Saturday and Sunday. So I have Saturdays and Sundays my classes I will try to do my best to offer also this seismic and surveying on Saturdays and Sundays, but it will be after I finish the class. This is one option, option one. Option two, during the weekdays. I know weekdays you are tired and are working, but nowadays you are working from home. You are not working, you don't go to the field, you don't go to the office anymore. So I don't, but I don't know when we will go back again to work in the offices. So weekdays, I can select Wednesday, for example, from 4:30 to 7:30, for example, p.m. obviously. Or on the weekends, I will pick Saturday, because Sunday probably you are next day you'd like to sleep early. All of you are in California, as far as I know, to the best of my knowledge. I don't know how many of you are in the East Coast. I believe one. Anyhow, think about it and let me know. Also, Saturday or Sunday between 4:30 to 7:30. Or I can pick weekdays like Wednesday, for example, Wednesday in the middle of the week, the hump day, as we call it. So tell me, which option do you prefer? Do you prefer option one, which on the weekend, Saturday or Sundays, late in the afternoon, okay, after I finish the national exam teaching, or the weekdays, like Wednesday, I can pick Wednesday, for example, uh, once a week we're going to meet, because as I told you that it will be a form of workshops that we are going to solve problems, and we will do it workshops. It will be in a form of workshops, and I will do my best to but I need your feedback. Always I need your feedback as far as problems we need to solve, topics to be covered, and so on, because you are the driving force in this case. You are telling me, if you want me to vote right now, we can vote. We are a democratic country. We are going to vote. As all of you know, November 3rd is coming very soon, which is election day. We're supposed to go and vote for, I don't know, it will be vote by mail or in person or what. There are two different views, one saying by mail and one saying by uh, in person, where physically we go over there and vote in person. So we will do our best, or I will do my best. And it seems to me there is a feedback from you. I prefer weekdays. Okay, so I will get one vote. Weekdays instead of Saturday and Sunday. I don't know. It's a preference. Probably if I can hear it from the rest of you guys, I will send an email. Um, um, I am flexible because I prepared one for the weekend, to tell you the truth. But I can switch it back very easily to weekdays. I did not reserve the webinar yet. I put the dates, and if you can give me an email, what is your preference? I really appreciate that, because I need to accommodate all of you. Okay, I don't like anybody to come to the class and he is tired and he cannot focus and something like that. Okay. And also I need your feedback as far as topics. I'm very flexible as far as covering any topic you want. You have access to the on-demand 24/7. The CBT, you have it in your hands. So all what I needed from you, I need you to sit and study and do your best. Okay. Let me stop here, and please email me about your preference, and keep studying, please. Keep coming with questions. Come up with some challenges questions for me. Okay, thank you very much. And the first thing that we will do, the first meeting in July, I will go over the retaining wall. It's a very interesting problem. I will go over it one by one for you with the solutions, and for every part of it, it's about 6 or 7 parts, I believe, and it will be very interesting problem. Okay, thank you very much, and always get in touch with me, please. Okay, thank you. Bye-bye.